Take it away.
Hi, everybody. Welcome to the CLARiTI webinar series. Today, we'll be hearing from the SCAN team about all things SCAN. I wanted to welcome you here. My name is Sterling Johnson, one of the PIs in the CLARiTI project. And let me turn it over to Erin Chin, who will give us a few announcements.
Thank you, Sterling. You can move to the next slide, please. All right. Oh, thank you. So I'll start off with our site initiation visit. So this is an initiation visit that you'll be joining our central monitoring service. We just want to congratulate our 6 sites that have officially gone through their site initiation visit. So they're one step closer to that site activation letter from the Wisconsin team. We do have a couple more sites scheduled. We've got Stanford, Johns Hopkins, Wake Forest, UC Irvine, and UCSD on deck. As a reminder, priority will be given to sites based on their site readiness. So continue to work with your CLARiTI project coordinator and the regulatory team working through the readiness checklist. And then just to update everybody, we will have 2 dates per month with the central monitoring service until all of our sites are initiated. Next slide, please. All right, and then our return of results brochure is now live. So thank you so much to our return of results core and Phoebe, our communication specialist, for putting this lovely brochure together. It is now IRB approved and available for use at the protocol level. So sites are able to add a site logo, add some contact information. Any additional updates will need to be IRB approved prior to use. So there's a box link there. So that is available for sites to use as needed. Next slide, please. All right, I will pass it off to Heather from NACC.
Hello, everyone. Today, I'm excited to share that University of Washington has signed the sub-award from University of Wisconsin, and the award lines are being set up. So with this step, NACC will begin submitting requests to the University of Washington OSP to draft your sub-awards in the coming weeks. So we've been busy with your sites and your finance teams to collect all the documentation, and 18 of the 33 sites are ready for this submission. So the next steps will be that your grants offices will be hearing from the UW OSP to reach out with any questions and ultimately issue the subaward. Your role today is to ensure that your site is ready for submission. So listed on this slide here are sites that are pending some documentation. So folks on this slide, if we're not already communicating with you in the last week or so, we'll be reaching out with what is pending. And also coordinate with your grants teams to be responsive to UW OSP when they reach out. So what does this mean for timing? Phoebe, if you want to go to the next slide. The review process will take approximately 6 to 8 weeks. So we're anticipating the first issued subawards will initiate in late December, but the majority will be processed in early 2025. So as always, happy to answer any questions that you might have, and we'll look forward to more on that to come. Next slide, please. Also this week, NACC launched the ADRC Program Community Forum, which is powered by Discourse. This is a centralized hub for Q&A and an additional communications channel for all things ADRC program, as well as CLARiTI. So those of you that are ADRC members and CLARiTI imaging personnel should have received an invitation to join on November 19th. So please respond to that. Within the forum, you can ask and answer questions. And I've put on here screenshots of the CLARiTI groups that have been set up already and are moderated by the CLARiTI staff to answer questions that you have. So we encourage you to use that. Next, I'm going to pass it off to Beth.
Thanks, Heather. Okay, so we're going to hear from SCAN today. Before I hand it over to them, I just want to briefly give an overview of how SCAN fits into the ADRC imaging ecosystem. So SCAN started in 2021, and it was really an initiative that resulted from I think, an excitement across centers and a specific recommendation that we were interested in collecting and sharing standardized PET and MRI data across the sites. So because of that need, SCAN was formed, And what they've been doing is really, implementing this. So they've been helping us, see this need. They've been helping sites implement these standardized acquisitions. They QC the data, they analyze the data, and then they work with both LONI and NACC to share the imaging data to the research community. So one missing component of SCAN was actually resources for the sites themselves to collect this data, as well as a specific study protocol focused on scientific gaps. So that's where CLARiTI, I think, fits into this. So this was also a need communicated from the sites and really launched, from the sites. So this started at the end of last year. So to kind of summarize the collaboration between SCAN and CLARiTI, so SCAN has been, already, working with the sites, analyzing the standardized imaging. Very excitingly, this data, which reflects thousands of scans, is now currently available to the scientific community. We're going to hear about that. One issue with the current data set is because of the lack of study protocol, there is missingness. So it's many participants from the ADRCs that have undergone one form of standardized imaging. They don't necessarily have other types. So there's participants that might just have only an amyloid PET scan, for instance, or only a tau PET scan. So that's something that we think is going to reduce as we go on. So for instance, with the P30 requirement, this is also standardized imaging, but there's a requirement that both amyloid and tau PET and also standardized MRI is collected within the same participant. So this here, we're going to see complete sets. And also this isn't a requirement for CLARiTI. So with CLARiTI, we're doing standardized amyloid PET, tau PET, and MRI, both at baseline and also 2 to 3 years after baseline, along with paired blood samples as well. Can you go to the next slide, please? So within CLARiTI, in terms of the PET side of things, as I mentioned, there's a requirement that the amyloid and tau PET is following these standardized SCAN protocols. Some sites are also going to be doing FDG PET. This is an optional PET modality that may also be coupled for a subset of sites. Next slide. And then for MRI, so for CLARiTI, the MRI session, it has to include the SCAN compliant, both T1 and FLAIR images. But then there's various other combinations that are possible. So in addition to the T1 and FLAIR, the SCAN compliant, we expect sites to collect their own site-specific sequences. There's also the options, if the sites want to collect additional SCAN compliant sequences, which are effectively the same as ADNI4. And there's also these advanced research sequences that we've had a previous webinar on as well. So this will really be up to the site to build, to do whatever MRI session that is appropriate for their site, assuming that they have the SCAN compliant T1 and FLAIR included. That's the strategy with CLARiTI. All right, next slide. Okay, and then this is just a quick slide to really remind everyone that the SCAN data, which we're going to be hearing about, is currently available. This data set is pretty remarkable. It reflects thousands of analyzed images. It reflects the outcome of this work that SCAN and the sites have been doing for the last few years. The data, from a data access standpoint, is very straightforward. So you submit a data request through NACC, and shortly after that request is completed, you'll receive extracted values from both the PET and MRI side in the form of spreadsheets. You'll also be routed to LONI to be able to actually download the actual image data itself. So we'll put the link for initiating this request in the chat box now. But just this really is a very exciting time, and anybody can access this data. So I'm now going to turn it over to the SCAN PIs. So we're going to be hearing from Bill Jagust from Berkeley and Cliff Jack from Mayo, who lead the PET. Bill leads the PET core, and Cliff leads the MRI core for SCAN. So Bill, off to you.
Okay, so this is the makeup of SCAN. These are the teams. As you heard, Cliff and I are MPIs. All the work is, the imaging work's being done in Berkeley, Michigan, Mayo, and Davis, and Lawrence Berkeley Lab, and these are our collaborations. So let me start out with the goals of SCAN. So really, the goal is to standardize imaging in the ADRC program and to have uniform protocols for collecting imaging data, for standardizing analysis, and making this compatible with other large data sets, particularly ADNI. So the first few slides I'm going to go over are the big picture on SCAN, and then I'm going to get into the PET story. So again, for all images, MR and PET, we're archiving them and curating them, and we're also producing quantitative numerical data, and these are available through LONI and NACC. And these images are combined across all the Alzheimer's centers into a single data set, and it's all linked to other NACC data that includes the UDS and eventually autopsy data. And all of this is available to researchers everywhere via the NACC data front door. So I'm going to give you some of the history. It's similar to what Beth just told you, but a slightly different perspective. And that is that, for a long time, ADRCs were collecting images using their own protocols, whatever those might have been, and they were doing their own analyses on the images. And most of these image acquisitions were funded through affiliated projects like R01s that ADRC investigators had. And in 2017, there was a work group that had that made the point that, gee, we should do something about this to standardize it. And then an imaging steering committee was formed. And ultimately, NIA funded SCAN. We got the original funding in 2020 and began to receive data in 2021. And this really ushered in the first new era in imaging in the ADRCs, which was the acquisition was standardized. And that is, we have a standard protocol for getting the scans, and we have a standard analysis protocol for analyzing the scans. Again, both MR and PET. But still, the funding for SCAN didn't include funds to actually get and acquire images. These were still being obtained through affiliated studies. And this has changed in the last year, first with the funding of CLARiTI, and ultimately with the funding of the new P30 round that are going to produce funding for obtaining scans. So this is the second a new change in the ADRC imaging, which is that we're using the SCAN protocol for CLARiTI and for the P30 acquired images. We're using SCAN labs to analyze, and as I said, there are now funding mechanisms to acquire the images through both CLARiTI and the P30 mechanism. So what have we been doing since 2020? I'm going to go through this quickly just to tell you how much work we've been doing, quite a bit, surveying sites, developing the protocols, developing pipelines, tracking the data flow between labs, training sites. We had one-on-one meetings with the ADRCs that NACC assisted us with. We've been integrating data analysis between all the different analysis labs and between LONI and NACC. We've developed data dashboards with NACC, and you've just heard about those today. There's been a dramatic increase over the last couple of years in submissions that I'll show you about. One of the things we decided to do was to deface the images for privacy, remove facially identifying information from the scans, and Cliff is going to tell you more about that. That set us back a little, but we've basically caught up now. And then I'm going to end by telling you a little bit about what we're going to probably be seeing in the future when we go in for renewal of SCAN. So this is the big picture of how SCAN works. The Alzheimer's disease centers essentially upload their data to LONI. Many of you have done this. Probably most of you have done it in one way or another. And these, again, are funded either by the affiliated projects, which is pretty much all the data I'm going to show you today, but also now we have funding from CLARiTI and from the P30. So these images go from LONI to the quality control in Michigan, quality control at the Mayo Clinic, and get their facial information removed, and they're curated at LONI. From there, the images are analyzed, downloaded from LONI and analyzed by SCAN labs. For MR, it's UC Davis and the Mayo Clinic, and for PET, it's Berkeley. And then through NACC, we create a lot of numerical data. So we extract information from the scans to create centiloids, SUVRs, brain volumes, brain cortical thickness. We create methods documents, data dictionaries, data dashboards, technical manuals, all available at NACC. And this is all available to researchers everywhere. So this is a plug for the website. If I'm not going to go through this, but if you have questions about SCAN, this is the first place to go, scan.nacdata.org. It has all the information about startup, technical manuals of how to acquire images, how to check your QC status. You can see your own SCAN data. This really is the one-stop shopping for SCAN. So just to show you how our images have really increased, this is just a graph to show you for PET and MR, the large substantial increase from 2022 to 2024. And the next slide really shows this just for PET graphically. But you can see we have over 4,000 PET scans, 33,000 MR exams with multiple series, about 6,000 T1s. And this data has come from 35 Alzheimer's centers. And these are the cumulative uploads from PET scans. 25 ADRCs have uploaded PET data, so not everyone yet. And the number of scans they've uploaded has ranged from 6 to almost 800. I just want to point out that almost all of these scans have been uploaded out of the generosity of the ADRCs. Most of these scans were paid for by affiliated studies, and we really worked with the ADRCs to upload their scans and to get them collected according to our protocols, and it's really worked well and paid off. So just to tell you where we're at, so most of the scans have come from these affiliated studies, and these are the numbers that have been uploaded for PET and MR. These are the numbers that have passed QC and have been pre-processed for PET, analyzed, and then linked to NACC data. So we have over 3,000 scans that are really ready to analyze. And actually, this slide is about a month old. And if you go to the data dashboard, you'll see the numbers have gone up by about 400 or so. Same thing for MR, passed QC and pre-processed, analyzed, and linked to NACC data. So several thousand scans for MR and PET that are available. And CLARiTI and P30 funding streams are going to generate a lot more images. You'll see that on my last slide. I'll get into that in a little more detail. So if you go to the SCAN website, you'll see the acquisition times and all of the protocols for acquiring images. I just want to show you briefly that we're accepting these tracers, PIB, florbetapir, florbetaben, and NVIDIA. And these are the acquisition times. Again, you don't need to write this down. You can obviously, the slides will be available, and this is all on the website. And for tau, fluortaucipir, MK6240, PI2620, and GTP1, again, these are the times, and these timings are important for quantitative accuracy. And then we also are accepting FDG scans. So there's some flexibility for the times for PIB and FDG, but we would like sites to use these times for the other tracers. And these are the number of scans that have been analyzed. You can see, again, when you start to break them down by specific tracer, the numbers are obviously smaller, but we can combine these, as I'll show you, and that's really looking very, very good. So Beth already made this point. I'll just make it again, that because in SCAN, up until now, there's been no SCAN protocol. That is, we don't ask the sites to acquire any specific type of image. We've simply been accepting whatever the ADRCs want to give us. And so some individuals will have an amyloid PET, a tau PET, and an MR. That's what you see here, 525 subjects. But some subjects will only have an amyloid PET scan, 446, only an MR scan, et cetera. So the overlap is kind of limited as of now. So I don't think this is going to be a problem for very long. First of all, we're probably going to reach out to ADRCs to see if we can find additional scans on participants with only an amyloid PET, for example. We'll probably reach out and ask whether you could find an MR on this subject, for example. So we'll be pestering you about that in the coming months. But also, as Beth pointed out, as we move to the CLARiTI and P30 funding, there's a protocol. So each individual in these projects are expected to have an amyloid scan, a tau scan, and an MR scan. So we think this picture is going to change. So I'm going to tell you a little bit about the data now, just to pique your interest. These are the diagnoses in PET now. I'm going to focus on the PET data. And these are the diagnoses. And you can see that the majority of individuals in our database at this point have normal cognition, but there's a substantial number with MCI and Alzheimer's disease, and then other dementias as well. So this is different from a lot of projects like ADNI, where we're focusing only on the AD continuum. And these are the breakdown of the etiology of MCI, again, that I thought you'd be interested in. So again, the majority of them have Alzheimer's disease, but there are quite a number of other clinical diagnoses: Lewy body disease, other neurologic diseases, vascular disease, FTLD, et cetera. So again, this information is all available at NACC through the uniform data set, and the SCAN data are linked to all these diagnostic information. So now I'm just going to show you some of the actual imaging data. Again, most of these scans are available to be downloaded, but here I'm just going to focus on the numerical values. I'm not showing you images. And this is just to show you that across the different tracers, PIB, florbetapir, florbetaben, and the NAV compound, when we convert the numbers into the centiloid scale, and all the centiloid numbers are available at the NACC database, when we convert them to centiloids, all of the tracers look very similar. So these are the cognitively normal people. You can see the range and variability is very similar. These are the MCI patients. These are the Alzheimer patients. And so if we choose a centiloid value of 20 as a threshold for a positive scan, we actually get fairly similar results in terms of proportions across these different tracers. So this the centiloid transformations seem to be working very well, and you can download amyloid data without worrying about what tracer was used to obtain it. These are just some data to show you some of the breakdowns by sex. So looks pretty similar at this point by sex. And this is the age versus centiloid graph. Again, these are pretty much sanity checks. We just wanted to make sure the data are looking sort of the way we expect them. And so, by diagnosis, obviously the centiloids are going up. These non-AD dementias, fairly small number at this point. So again, one of the nice things about the NACC database is it's a bit more diverse than many other databases. And I'm not showing you this to try to take home any statistical comparisons, just to show you that our sample sizes for some of the less represented groups, such as the Black and Hispanic, are getting there. They're not huge, but again, I'm hopeful that because of the emphasis in the ADRC program, we'll be seeing a pretty good diversity of individuals in our data set. And again, as this progresses, I hope that this is something that investigators will find useful. So now shifting to tau, and here I've just split up the tracers. So this is fluortaucipir, the tracer that has probably been around a bit longer, and MK6240, a newer tracer, but one still with a decent sample size. And I'm just showing you this data to show that in entorhinal cortex, the pattern of tau deposition is pretty much what we'd expect. Again, kind of a sanity check. And it looks very much the same for MK6240. And this is what we call the metatemporal ROI, which is temporal neocortex, brain regions in the inferior and lateral temporal lobe. Again, the patterns are fairly similar across these diagnoses, although we have to be careful. Not a lot of Alzheimer dementia participants with MK. But this is really sort of reassuring. And here's the relationship between amyloid on the x-axis and tau on the y-axis. And so here again is entorhinal cortex. And as we would expect, the more amyloid there is, the more tau. And this is the relationship for fluortaucipir. And this is the relationship for MK. And what I found reassuring is that the correlation coefficient is really almost the same. And for the metatemporal ROI, pretty much the same story. Amyloid versus tau in the neocortex, again, the correlation coefficients are very similar. So I'm going to just end by talking a little bit about what we're going to expect to see in the future. So we are getting ready to propose our renewal, and that will go in the spring. And so we've been projecting how much work we're going to have. And we are assuming that these affiliated studies are going to continue to upload data at the rate that they've been uploading them, which are 1,200 PETs and 17 MRs per year. So that's going to be one source of scans that we're going to work up. Then the P30 mechanism is expected to generate roughly 1,700 PETs. That includes both amyloid and tau, and 900 MRI exams, and that will mean 900 T1s and 900 flares. And then CLARiTI is going to generate potentially 1,600 PETs per year and 800 MRs per year. And when you add all those up, that is unbelievable. That's 4,500 PET scans per year and 3,400 MR scans per year. To put this in perspective, in ADNI, which has been going for 20 years, we just passed the 10,000 scan mark. 10,000 PET scans. So we are going to collect in the next 2 years what ADNI has collected in 20. So we're really looking at a substantial workload, and I'm not here really to complain about the workload. I'm here to get you excited about how many scans are going to be available. We're talking about numbers in the tens and 20,000 range. So our plans for renewal are to continue analyzing all these data from the affiliated studies and from the P30s and CLARiTI. We have identical processing pipelines, as I said, between all these data streams and ADNI for MR and for PET. One of the things we're going to institute in SCAN2, which, be curious to hear what you all think of it if you have thoughts, is a visual read of the scans, which will go back to the ADRCs. So we are going to do essentially what is being done in CLARiTI. We're going to piggyback on the CLARiTI mechanism for image reads and send the results back to the ADRCs to share with participants. And Cliff will tell you about changes in the MR sequences that will be an option as well. Just to again emphasize that all of this data is available at NACC, and it's all mergeable with all these other sources of data that are available at NACC. So this is the real strength of SCAN, that these images can be merged with data on genetics, blood biomarkers, neuropathology, cognition, all of these different variables through the NACC data platform and the NACC data front door. And this is essentially where you can, I just want to point out that there have been 600 data requests only since May. So people are starting to use these data, and I'm very excited about that as well. And again, just to point out how this is done, you can go to the public dashboard to see how much data you've uploaded and how much data there is available. And then you can submit a data request, which is quite simple. You can sign a DUA online and receive scan data very quickly. So we will, I think, move on to Cliff and then take questions after both of our presentations. So thank you. I don't think Cliff needs an introduction. So here he goes.
There we go. Okay. All right. Thanks, Bill. And so I'll just do the pick up where Bill left off, and I'll do the MRI part. These are the people who actually make the MRI part of SCAN work. You can see many people at Mayo who work part-time or spend a lot of their time on SCAN. It'll become evident in a minute or so as we get into the numbers why this many people are necessary. Then we have Charlie's group at UC Davis, also an integral part of the MRI core for SCAN. So the entities SCAN, ADNI, CLARiTI, and NACC are all clearly interrelated. Both Beth and Bill have already kind of talked about this, but just to kind of reiterate some of these points. There may be some confusion about how these different entities are related. So as Bill said, SCAN is a U19. It's an independent study with a specific mandate to standardize methods for image acquisition. Using ADNI methods. That was one of the mandates for the SCAN application, using ADNI methods. So ADNI, what's the relationship? Yes, SCAN uses ADNI methods, but obviously for a different cohort. CLARiTI, SCAN, what's the relationship here? SCAN helps with the imaging in CLARiTI, but SCAN is an independent study or an independent entity from CLARiTI. The cohorts are different, as Bill has said. And finally, NACC. So the SCAN images from SCAN and numeric data are linked with clinical and other data at and by NACC, but SCAN is not a subsidiary of NACC. So these are just some of the relationships. Now, what is the organization of the MRI core? There are two main components. One is what could be called a central lab functionality. This exists at the Mayo Clinic in the RE Alzheimer's Disease Imaging Research Lab. And there are two subcomponents of this, which I'll address in series here. And then secondly, the second main component is production of numeric analytic output. So let's take the first part of the central lab functionality. What SCAN does is, first, we create a master protocol. The SCAN protocol is equivalent to the current ADNI protocol, which right now is ADNI 4. We then create vendor and operating system specific protocols, send these e-files to sites, and certify every scanner in SCAN using any phantom that you want. And here are the people who are integral to this effort: Brett, Arvin, and Kaylee. Now, the term SCAN versus exam versus series. Again, maybe some confusion here. So what is an exam? And well, first of all, let's go backwards. What's a series? A series is a single acquisition. So T1 is a series. FLAIR is a series. T2, 3D T2 is a series. The exam is the sum of all these. Unfortunately, the word SCAN is used in three different ways. It's used to mean exam sometimes, it's used to mean series sometimes, and it's also used to mean the study, SCAN. So I'll try to use these terms exam and series in a way that is unique. What you see that there are 8 different series types in the full SCAN protocol. T1, FLAIR, T2, gradient echo, diffusion, arterial spin labeling, perfusion, task-free fMRI, and then a high-resolution series for hippocampal volumes. An important aspect of SCAN, as with ADNI, is that these are all product sequences, meaning that we only use product sequences or series that are provided by the manufacturer and are FDA approved for clinical use. Now, why is this relevant? Why is this important? Here are a couple reference papers. These are from ADNI, but they're completely relevant here, describing different series types, et cetera. And then in the second one here, there is a section describing the difference between product series types and experimental or works in progress. I won't go through that here, but an important aspect of SCAN is that everything uses vendor product. Now, people who are familiar with SCAN have probably realized that there's a choice that users are offered, option 1 versus option 2. So option 1, it's very simple actually. Option 1 is that you can, if you want, only do the 2 core series types, T1 and FLAIR. And the rest of these we can call advanced SCAN series, for lack of a better word. But option 1 is just do the 2 core T1 and FLAIR, and then have the rest of your exam composed of whatever else you want to do that you want to do at your site. Option 2 would be to do the core T1 and FLAIR, and then select, again at your choice, which of these advanced series types you might want to add to your standard SCAN protocol at your site. And I label these as advanced. In reality, I would say from a complexity standpoint, maybe the 4 in yellow are what I would call advanced, but these are all, you can call them non-core. So the second major functional aspect in terms of central lab functionality is this: series type assignment, sorting, quality control, etc. Now, what does series type assignment mean and why is it important? If you were to simply open up the names of different series types in the DICOM header, and you would see this sort of alphabet soup of different names, all these things mean exactly the same thing. These are the series descriptions that you might see, but they all mean exactly the same. So this alphabet soup means, it all means 3D T1. So what's really needed is, it's a huge headache for users to try to, if they want to pick a specific series type for analysis, to sort through this hieroglyphics. What's really needed is a Rosetta Stone to compress all of this stuff into a single series type. And that everything there would just be labeled a 3D T1. Same issue for FLAIR, same issue for 3D T2. So this is probably the first step that we do at Mayo when we get all these scans, is to compress or collapse all these different series type names into these standards. Now, a second step in the quality control and findings area is that there two aspects of quality control. One is protocol compliance. The second is visual quality control for things like patient motion. And then all exams are examined for potentially medically useful or medically important findings, things like microbleeds, infarcts, etc., by our trained analysts, and all positive findings are verified by one or more Mayo neuroradiologists. So Bill showed a slide something like this, the cumulative input of PET scans. This is the analogous slide. This would be cumulative upload of MR scans into SCAN as a function of upload date. You can see that things started out kind of slow for the first year, but since then, things have taken off. And at present, this slide's a week old, a couple of weeks old, maybe, about over 6,300 different MR exams that have been uploaded to SCAN. The workflow, once we at Mayo get an exam, then goes by series, not by exam. So everything goes from, the workflow is handled at the series level. So these 6,300 exams have produced 35,000 different series. And once they're labeled, the first thing we do is we peel off things that are irrelevant, like scouts or calibration scans. We peel off series that are irrelevant, like some people upload MRI angiograms and this sort of thing. And we get, after the full quality control, all the steps, we wind up right now with 15,000 different series that have passed all the quality control and are available for users. So of these 15,000, about 5,000 or so are T1s, about 5,000 or so are flares, and so on. This is the data that's now available to users. This takes a ton of work, as you can imagine, and these are the image analysts who do all this work, have done all this work. It takes a ton of IT infrastructure. These are the people at Mayo in our IT group who've handled all this. In terms of findings, this is just some early data, if you will, but about 5% of all the participants have subcortical infarcts. Another 5% have other findings like meningiomas. About 15% or so have one or more cerebral microbleeds. I don't show cortical infarcts here. I'll say something about that in a second. I mentioned the neuroradiologists are double check, if you will, or review every positive findings. This is the group who does this work. A lot of you might recognize Tejal Kantarsi, one of our team. So I mentioned cortical infarcts, and one of the questions that was given to folks that we would like input on in order to design or put together what SCAN2 will look like centers on this. So these are just some examples of exams that have been uploaded to SCAN. You can see some people here with giant infarcts. You can see somewhere on the far right with a metallic artifact from a shunt valve, and you can see the shunt in the right frontal white matter. And the question to this group, and we hope we'll get feedback on this, is, are these useful to the ADRC community? Because it's probably unlikely that at least MRI quantitative information is going to be gotten from these kinds of scans. Now, Bill mentioned defacing. So as everyone knows, this is a graph from a paper Chris Schwartz wrote. As everyone knows, when a participant volunteers to be in one of these studies, the expectation on the part of the participant is that all their data is going to be de-identified and blinded, all their medical information, and that there is a bright red line denoted in this graph between a person's private medical information and their public identity. The issue or the problem is that using kind of updated, but not really terribly fancy technology, it's possible to reconstruct the face from both MR and PET images. And then it's also possible using publicly available AI methods to match that face to photographs, thereby creating a link between a public person's identity and their private medical information. And so Chris Schwartz has really taken ownership of this and has done some fantastic work here in looking at different methods to de-identify or deface scans They're done. So defacing is actually part of the workflow for MRI and for PET in SCAN. This is from a paper Chris recently wrote. I won't go through any details here, but these are the different image types that require defacing. And this is a reference paper by Chris. It's about ADNI, but it's completely irrelevant here. It's a relevant reference paper if people are interested in more information about defacing. So we've talked about central lab functionality in SCAN. There's also the numeric analytic output, which is the second part, if you will, of what the MRI core does. You can see that Charlie's group does the free surface morphometrics, white matter hyperintensity, and then other metrics are output by the group here at Mayo. These are data from Charlie's group. You can see hippocampal volume as a function of clinical group membership. Hippocampal volume declines as cognitive performance by group declines. Hippocampal volume by SUVR, FTP, and Merck, the Merck tracer that Bill just described. No surprise, hippocampal volume falls as the top head SUVR increases. Data again from Charlie's group. This is hippocampal volume as a function of age, declines, no surprise. Hippocampal volume is a function of MoCA. No surprise, the better the MoCA, the higher the hippocampal volume. Here's white matter hyperintensities. Their associations are all reversed, so it goes up with age. No surprise there. And as WMH gets higher, higher MoCA gets worse. So these are diffusion MRI data. This is mean diffusivity. Here are 3 different regions of interest, 1, 2, 3 across the columns. At the top, you see mean diffusivity as a function of age. So higher mean diffusivity is bad. You can see it goes up with age. And it goes down as MMSE score gets better. This is a different metric, fractional anisotropy, also from diffusion. FA, so here, higher FA is better, so it goes down with age and it goes up with better MMSE scores. This is a different metric that's output by our group, task-free fMRI. The metric is called NFQ, network failure quotient. This is a metric that was derived by Dave Jones some years ago. It was derived or designed to capture network failure in people with Alzheimer's disease. We supply this. This data has been uploaded. The question for, again, there's a red star here, meaning the question for that we'd like to get some feedback on is, do people think that this is a useful metric for SCAN? It's a summary metric, but it wasn't designed for all comers. It was designed for people on the Alzheimer's spectrum. So useful, yes or no? Next, I'd like to talk about the advanced series types in SCAN. And again, I won't talk about everything. I'll just talk about these 4 different advanced series types here, starting with diffusion. So SCAN offers both a very simple diffusion protocol, but also a more, if you will, modern or advanced diffusion protocol that consists of 3 different shells, B shell acquisitions. With this, we can do advanced kind of naughty processing. I won't show any images for this. Another one of our advanced options is this so-called ultra-fast imaging, 3D T1 and FLAIR. And what does this mean? So there's a new technology that's not available in all vendors and not available in all platforms, but some, and this is kind of technology that's going to, this is a hot area in MR engineering right now. This is technology that's going to make its way throughout MR fleets over the coming years. Compressed sensing or some other vendor-specific variant thereof is used to greatly undersample in time, meaning much faster acquisitions, but using smart reconstruction methods to get similarly good diagnostic quality images out. So the obvious benefits are reduced motion artifacts by reducing acquisition time, and then much faster potential MR exams for things like safety screening and for clinical trials and also for patients who are being treated. So here are some examples of the ultra-fast MR that we offer in SCAN now with Philips and GE, 2 different vendors. The standard 3D T1 is what they look like and the time, acquisition times across the top. And then at the bottom, you can see ultra-fast kinds of acquisition using compressed sensing or hypersense reconstruction. You can see a little bit of loss of signal to noise. It's what you would expect, but the acquisition times are under 1/3 of what they are for the standard. This is what the flares are that we look like. You can see we undersample a little less aggressively because there's less signal to noise to burn in a flare than there is in a T1 weighted image. But still, with a nice time savings, you can see very much comparable image quality using these modern techniques. The second advanced image type that I'd like to point out, or series type that I'd like to point out that's offered by SCAN, is this multiple post-label delay acquisitions for cerebral blood flow. Here we have 5 different post-label delay acquisitions, and the advantage of this over a standard sort of acquisition is that by having 5 different post-label delays that bracket about 2.5 seconds between the labeling time and the time that the bolus appears in the cerebral microcirculation, it captures a range of cardiac outputs, which can be highly variable, particularly in an elderly population. So we can get much better looking cerebral blood flow maps and arterial transit time maps. The last advanced scans image type that I'd like to point out is advanced heme imaging, so-called, or advanced iron imaging. And there are a number or several questions in our questionnaire to the ADRC groups about your opinions on this and what SCAN should look like going forward. So our approach is a multi-echo gradient echo kind of approach, 5 echoes with this resolution. So 0.5 by 0.5 in plane and 1.8 millimeters through plane. You can see this is anisotropic. It's not cubic voxels, it's anisotropic. The advantages of this, in my view at least, are 1, you get clinical care quality microbleed detection. And 2, with a single acquisition, we give 3 different kinds of outputs. So we get a standard gradient echo image from the 4th echo. This is what the microbleed counts for inclusion and safety monitoring that the FDA and the pharmaceutical companies have used for grading microbleeds. We also get SWI, susceptibility weighted images, which are a lot of radiologists, I think, are wanting to move to this type of acquisition or this type of processing for microbleed detection because it's more sensitive. The problem is none of the FDA guidelines are based on this approach. And the third output we get is quantitative susceptibility maps. The disadvantage of this approach is that we don't use the standard spatial resolution, which is isotropic 1 by 1 by 1 or better, recommended by the International Society of Magnetic Resonance in Medicine. Nonetheless, this is what some of these images look like. So this is a standard gradient echo image from the SCAN multi-echo gradient acquisition. This is what the QSM map looks like. This is what this exactly the same standard gradient echo image looks like with the ISMRM acquisition, and this is what the QSM map looks like. The neuroradiologists here at Mayo that we've shown this to are not very happy with trying to count microbleeds on this sort of acquisition that I'm showing right now. They much prefer something that looks like this. So finally, second to last slide. Just some notes about where does SCAN fit in with CLARiTI again. So if you open up the CLARiTI website, you're given 3 different options for MR protocols. There's the advanced, there's the full CLARiTI, and then the heterogeneous, etc. So everything in yellow here is just SCAN. The file names have been changed from SCAN to CLARiTI, which is, we wanted to do that. It's appropriate to do that so that the tracking of files as they move through the database system can be kept track of what's CLARiTI, what's SCAN. But everything in yellow here is just SCAN, and the workflow for all this stuff in yellow is just exactly as I've just described it for SCAN. So this is the last slide I have, just a summary slide. And I hope that it's become apparent that there is lots of data available. Bill has described a lot of PET data. I hope you're convinced that there's a lot of MR data, over 6,300 exams at present. 35,000 individual series have been curated. 15,000 of these have passed all the steps and are available for users right now. Numeric analyses are available. Charlie's group, as well as our group at Mayo, have provided numeric analyses. And as you can see, lots of work went into collecting, curating, and analyzing this data, and we hope that people will use it. That's all that I have, and thank you for your attention.
Thanks, Cliff. Thanks, Bill.
Stop share. Okay.
Okay, we have 10 minutes for questions. See Charlie's hands up.
I want to just make one quick comment, as about a dozen or so of the ADRCs are also in diverse VCID, and I want to remind them that Cliff and I have done a lot of work to align. So everything you heard Cliff talking about, diverse VCID sequences and protocols are identical, making that opportunity to share with SCAN transparent.
Thanks, Charlie. To that, I'll just add that if the DVCID image has been collected within 12 months of the CLARiTI protocol, you have the option, and your participant has the option of just sticking with that DVCID and not collecting an additional MRI. We would like the additional MRI, at least the T1 and the flare, but we're mindful of participant burden. So the DVCID image will suffice. That exam will suffice. Thanks, Charlie, for being flexible with that.
I have a question.
Yeah, go ahead, Lisa.
Yeah, I was curious. So we have several ADRC participants who are also enrolled in ADNI, and they're just really interested in imaging. Excuse me, losing my voice. So I wondered is there a world in which we can co-enroll ADRC participants in both ADNI and CLARiTI?
It's a great question, and we really appreciate their willingness to do these things. If they're already in ADNI, it accomplishes the goal. Their images are there. They're in the public. They're accessible to all of us, and they're linkable with NACC. So we don't need them, or we would ask you actually not to co-enroll them in CLARiTI, just because of the extra radiation burden that they might receive from that. And in fact, that's one of the exclusions, one of the few exclusions we have. If they're already in a longitudinal PET imaging study, the FDA has asked us not to enroll them in CLARiTI. So they would need to, they'd have to discontinue whatever study they're in order to participate in CLARiTI. We don't want that. For ADNI especially, we want them to continue. I hope that answers that.
Yeah.
I have one just follow-up question about that, for participants in leads who are no longer getting imaging because they're at the 48-month mark. Are we able to enroll those folks into CLARiTI, even though they're technically in a longitudinal PET study, but not getting PET anymore?
I think that makes a lot of sense to enroll them in CLARiTI and do whatever you can do in CLARiTI before you maybe re-enroll them in leads once the renewal kicks in. Yeah, there's ways we can help you do that. We can talk more about that if you want.
Dr. Kuko?
Hi. Can somebody say a little bit about the longitudinal aspects of this, or plans for the longitudinal aspects of continuing to get scans of one sort or another?
So yeah, so within CLARiTI, there is a longitudinal component as part of the study protocol. So participants that enroll into CLARiTI will do PET and MRI and blood at baseline, and then also again 2 to 3 years after that first visit, if they are retained. But I think for the P30 and also the affiliated studies, that is going to be site-specific decisions on the longitudinal data collection in those contexts. Cliff, do you want to?
Yeah, I just want to say that I forget the number, but a number of, it's in the hundreds of people who've come back for one or more serial MR exams. So that is already baked into SCAN.
Yeah, I mean, I mean, we do have longitudinal MR and PET data in the current SCAN database, but I think Beth said it right. It's really up to the individual ADRC. I mean, in SCAN, we have, you know, three pipelines delivering images. CLARiTI is very specified, but the P30 and the affiliate studies are not specified. It's really up to the individual protocols at each ADRC.
There's a question.
Oh yeah, were you gonna do the Q&A? Okay, thanks.
Sure. Yeah, there's one question. So for the P30 MRI exam, so this is the new requirement for sites to collect 24 amyloid tau PETs with the MRI. Will there also be options to just do the core series or the full SCAN protocol, or is it the expectation hope for the full protocol to be collected? So my understanding is that this is only the T1 and FLAIR is the expectation to meet that requirement. So the SCAN compliant, which is the ADNI4, T1 and FLAIR are required to meet that that expectation, not the full SCAN protocol.
I just have one more question wanted to ask just about the UDS4 transition and if any of that will impact CLARiTI. It seems like the CRFs are designed to kind of capture data from UDS3 or UDS4, but just want to kind of make sure that we shouldn't anticipate any issues with our personal transition date for that.
It's a great question. Yeah, what she's talking about, what Laura's talking about is as we determine eligibility for CLARiTI, we refer to the source documents, which is the ADRC NACC forms, the D1 form, B9, and other forms there. And so we'll continue to use whatever is active at your site. And there shouldn't be any logistical problem. It's just based on where your site is with regard to your own transition from 3 to 4.
I think there are interesting opportunities though with UDS4. There's more integration on kind of biomarkers and how sites are using biomarkers during the diagnosis. And now there's going to be this, there's the SCAN process data, the CLARiTI data, and these reports that are going to be given back to the sites with visual reads. So I think there's potential, and we don't know how this will be integrated into those forms, but that will be site specific.
So, I mean, I've been part of the working group on this, and I mean, it's not done yet, but there is definitely a plan to try to integrate imaging data into the diagnostic, into the decision tree for diagnosis. And so I think you'll be able to indicate what sort of imaging data and how it was analyzed and so forth.
Great. Oh, there's one more question. Is it correct to say ADNI and CLARiTI currently have disjoint sets of participants? So I think this is an interesting question. So by definition, we do not want to enroll participants into CLARiTI that are currently in ADNI, because this idea of, it doesn't make sense to do multiple PET scans on these same participants, but it is possible that somebody participated in ADNI previously and would enroll into their ADRC or CLARiTI. But I think the idea generally will be like they should not be overlapping these odd exceptions.
All right. Thank you, everybody. I see we're at time. I hope everyone has a lovely holiday season, and we'll see you again for our next CLARiTI webinar in January. Take care, everyone.